Okay, let's just get a little bit more practice graphically determining the limit of a function and some notation. The limit of f of x as x approaches a is equal to L. This is by our definition. If and only if the left-hand limit and the right-hand limit are equal to the same thing. So we talked about that, and that's the notation for it. This is a limit from the left, the limit from the right-hand side, and if so, then the limit is L. So let's just practice with that notation. So number one says, using this graph up here of f of x, approach -1 from the left-hand side. So as I'm moving towards -1 from the left-hand side, what's that value? Negative, looks like 1, 2, -3? Good. Okay, now let's approach this. The notation on this is the limit of f of x as x approaches -1 from the right hand side. So as I'm coming from the right hand side, I'm moving along here, and I'm approaching -1. What is that value? -3. Well, then what do we conclude about the limit of the function as x approaches -1? Right, so if the limit from the left is -3, the limit as you approach -1 from the right is -3, then it makes sense that by definition it is just -3. Okay, let's do the same thing, but this time our next notation we can kind of see it at the bottom of the page. It says, what is the limit of the function? Let me get that off the way. As x approaches 0 from the left. As x approaches 0 from the left, so that's right here. Now, I'm coming from the left-hand side, and I'm moving towards 0. Where do we find ourselves? -1. Very good. As I'm moving from the right towards 0, where are we? So the limit of f of x as x approaches just 0 is going to be -1. Good. Let's see if I can still see the image. And so the next one we're going to go 2 from the left, 2 from the right, and x approaches 2. So let me move it up. 2 from the left, limit of our function as we approach 2 from the left. What's that? 2 from the left is going to be what? 1. Good. Now let's go 2 from the right. 1. So what's the limit of f of x as x approaches 2? 1. Great. All right. Let's do 3 from the right. This changed up on us. So 3 from the right, 3 from the left, and then just 3. So let's go back up to it. So we're going 3 from the right first. Does not exist. Good. So add that in on your paper down there. What about 3 from the left? Does not exist. So what about our function? Does not exist. So what we want to write in here is does not exist. That was from the right. Does not exist. So does not exist. Okay. And now it says let's evaluate the function f at -1. So let's come back up here. F at -1 is equal to, at the x value of -1, what's our function equal? -3. Good. Let's plug that in. So -3. What's f evaluated at 0? Right here. Go to the x value of 0 and it's -1. What is the f evaluated at 2? When x is 2, 3. It's here. This is the closed circle, right? So it is 3. F of 2 is 3. And what about f of 3? Undefined. Yes, it's absolutely. It's on a vertical asymptote right there. So f evaluated at 3 is undefined. Okay. Now, tell me about the limit of f of x as x approaches 2. What did we get for number 9? One. Yeah, I think we got one. But is it the same as the function evaluated at f of 2? No, absolutely. So keep in mind the difference between the limit of a function and the function evaluated at that particular case. The limit as x approaches 2 is going to be 1. It's where it's approaching. The value of f at 2 is the x value of 3 because the closed circle is here. And this one's open. Okay? Alright, I think we have a few more over here for just a quick review. You don't have these, don't worry about sketching these images, just help me go through them fairly quickly. Okay, so we're going to look at, for this example, we're going to look at this function. As x approaches negative 2 from the left, negative 2 from the left, what do we get? 0, good. What about negative 2 from the right? So 0. So what's the limit of f of x as x approaches negative 2? 0. What's the function evaluated at negative 2? Negative 2, yeah, it's right here. It's hard to see. Alright, now what about this one? The limit of the function as x is approaching infinity. As x is keep on going, where does it stop? We don't know, right? So we say the limit doesn't exist. What about as we go to negative infinity? So I get on my function, I'm approaching negative infinity. What about it? Does not exist. Good. Alright, let's look over here at number 2. We approach the limit of f of x as x approaches 3 from the left. From the left, what do we get? It looks like 2. What about coming from the right side? 2. So what about just as it approaches 3 in general? 2. What about the f evaluated at 3? 3. Good. What about going towards negative infinity? Does not exist. Positive infinity. Does not exist. Good. Alright. 2 more down here. Alright, now we'll just say theta. Don't let it throw you off. Different notation, different values. Still the same idea, same concept. The limit of theta x as x approaches negative 2 from the left. Negative 2 from the left. What about it? Does not exist. What about negative 2 from the right? Does not exist. So what about the function in general? Does not exist. What about theta evaluated at negative 2? Undefined. Good. And what about the limit as x approaches negative infinity? So what happens as I'm approaching negative infinity? What is this thing approaching? 2. You see the difference there? Now it's approaching. It's going to keep on going, but we know it's approaching 2. We can see that it's a value. What about going in the other direction? What's it approaching? As I get on my graph, I'm headed towards positive infinity. Do I know a particular value that I'm going to approach? It approaches 0. Absolutely. All right, what about, let's look at number 4. As x approaches 4 from the right. Coming from the right, what about it? Does not exist. What about 4 from the left? Does not exist. What about 4 in general? The left hand and the right hand don't, then it just doesn't. What about theta evaluated at 4? Undefined. As we approach negative infinity, what are we headed to? 0. What about if we're going towards positive infinity? Looks like negative 1.